All right, so on Friday, when I said write the real form, we actually wrote the complex form. And so I wanted to correct that. All right, so the real form means it's going to look like this when we're done. So what we've got to be able to do is to take these cosines and sines, and we want to be able to convert them into x and y's. So we got to figure out, how do you take the cosines and the sines to x and y. Okay, and the way that the bridge, the translator that takes us from one to the other is the Pythagorean identity here. Okay, so what we do is the cosine, or the real part, that's really the x-coordinate, because this is the real axis, which is also the x-axis. So I can say that the x-coordinate is equal to 1 times the cosine of theta, or just cosine theta. That's this part. So this is the x-coordinate, also the real coordinate. All right, and then the imaginary coordinate, okay, the 3 sine is equal to the y-coordinate. So that's y-coordinate there. And even though it's not written, there's a 1. 1 times cosine is the x-coordinate. Okay, so over here I'm going to write y equals 3 sine theta. So don't notice that there's no I. I didn't bring the I. The I is part of the complex equation. It's just indicating that this is your imaginary, so 3i is up here, you know. Three i's there. So 3 is just indicating 3 units up. Okay. There was a handout up front that you need to get. Okay, now what you do is you're going to solve each one of these for cosine and sine. So this one, what you're going to do is isolate sine. So to do that, I'm going to divide both sides by 3. And I get y divided by 3 equals sine. Okay, and over here, there's nothing to isolate, but if there was a number other than 1 in front, you'd isolate that. So here we're going to isolate cosine, which just means I'm dividing both sides by 1, which doesn't do anything. This is still x equals cosine. All right, so I've isolated cosine, I've isolated sine. Okay, now you're going to use this Pythagorean identity, okay? Cosine squared theta plus sine squared theta is equal to 1. So if I squared both sides here, if I took this and squared both sides, I'd have cosine squared theta is x squared. So I can take this out and replace it with x squared. Okay, if I did this side, if I squared both sides, I'd have y squared over 3 squared, which is 9. So I can take this out and replace it with y squared over 9. And this whole thing equals 1. Okay, and now that's the real form of the equation. Okay, so now if I graph it, I can either graph either version I can graph. I could graph this version, or I can graph the real version. Either one doesn't matter, it'd be the same. Okay, if I was to graph the complex one, okay, that is the real number. And this is on the imaginary axis. So there's 1, and there's 3i. Okay, if I did it using the real form, okay, we know that 9 is greater than 1, so the larger value tells you that the major axis is y. The larger value is equal to the major axis. Okay, so in our head, that's really a squared, so a is 3. In our head, this is b squared, so b is 1. You see, it's the same thing. This would be 3, this would be 1, that would be -3. It's the same thing. So regardless of how you graph it, which form you use, it's the same thing. Okay, so on the second part, guys, we're using the Pythagorean identity again. Cosine squared theta plus sine squared theta equals 1. So cosine is the same as that. Cosine squared theta equals x squared over 25. And then these two are equal. So sine squared theta equals y squared over 4. Okay, and now solve each one of these. So this one I'm going to solve for y. This one I'm going to solve for x. this one for y. Okay, take the square roots. Okay, and this one would be 5 cosine theta. Yeah. Oh, I'm sorry. How about now? Okay. And take the square root here, and it would be 2. Okay, and now what we're going to do is substitute those into this. So that is going to be our real part, 5 cosine theta. And then this part is bi sine theta. So when I substitute that in, it's going to be 2, now the I sine theta. Okay. Yeah.